Hi CS50. This is Steve Michael, and this is an attempt to try to explain the process of going through the Vigenere Cipher program for CS50 and PSET 2. Any cipher starts with a plain text message. That plain text message gets put through some type of a conversion process, and out pops a ciphertext message. For Viginere, what we're doing is we're starting with our regular alphabet. For this example, I'm just going to use lowercase letters, although our problem actually requires us to be able to handle lowercase and uppercase. To start with, we take our alphabet, letters A through Z, alright, and we give them an index number from 0 to 25, A being 0, Z being 25. So our table of alphabetic indexes is right here. Alright, then we start with some plain text message. This plain text message here is meet Al later. Each one of those letters has an index value. So M is 12, as you can see in our index table. E is 4, T is 19, etc. We don't worry about spaces in our message, so I've got these grayed out. So we start with the plain text. Then we need to go and have some type of a keyword. And for the keyword here, I'm going to use the word bacon. B-A-C-O-N. Each letter in that keyword also has an index value. So B is 1, A is 0, C is 2, etc. What Vigenere does is it matches up that keyword with each one of the letters in our plain text. So as you can see, I've got B underneath the M in meat, A underneath the E, C underneath the E, etc. We skip any spaces so that the N in bacon goes underneath the A in Al. Then, since we've run out of our keyword, we restart it. So B goes under L in Al, we skip the space, A goes under L in later, C goes under A in later, etc. So we recycle our keyword as many times as we need to in order to fit the length of our message. Next piece. We add the index values of our plain text message and our keyword. Plain text message starts with M in meat. That index value is 12. It gets matched with our keyword with the B in our keyword bacon. That index value is 1. 12 plus 1 is 13. And the 13th letter in our index is N. That's the start of our ciphertext. I do the same thing with the next letter. E gets matched with the A in bacon. A has an index value of 0. 4 plus 0 is 4. So my ciphertext value here is E. The second E gets matched with the C in bacon, whose index value is 2. 4 plus 2 is 6. That second E gets changed to a G. Now we have a problem. T has an index value of 19. 0 has an index value of 14. 19 and 14 is 33. 33 is greater than our final index value of 25. So what we need to do is we need to cycle back around to the beginning. So if z is 25, A then becomes 26, B 27, C 28, D 29, E 30, F is 31, G is 32, H is 33. So 19 and 14 actually gets translated into 7 because of our cycling around, and our ciphertext letter here becomes H. Now the easiest way to do this calculation is with modulo arithmetic. So if I were actually doing the formula here, I would say the index value for my ciphertext is going to be equal to the index value for my plain text plus the index value for my key modulo 26, since we have 26 letters in our alphabet. That calculation will come up with an index value of 7, because if you remember, the modulo function goes ahead and gives you the remainder after the division is done. So 33 modulo 26, if I do 33 divided by 26, that's 1, remainder 7, and this becomes a 7. So I keep going like that. Any place where the addition of my plain text index plus my key index turns out to be greater than 26, such as here, with later T is 19, O is 14, that then becomes 33 again. This gets changed to 7. Alright, I hope that helps. I hope that it's not more confusing for some folks, but this is the concept behind Vigenere.